So hello everyone, this is Akshay here and welcome back to our GFG POTD streak of day 181. So as you have read the today's question maybe, and you may have found that the question is simple to understand, but maybe you'll be finding difficult in coding the same problem, right? Because at first glance, I don't think any one of you have faced the struggle of understanding the question that what we have to do. Instead, how we can do can be the problem, right? On trees में मैंने हमेशा बोला है यार कि whenever we are solving a question on trees, then do not dry run this whole test case. You can see that the tree is very large, right? Instead, you could just take this part like 1, 2, 4, 5, 7, 9, just this small subtree, and you can try thinking that how you can do it. That's the logic I always use to solve a tree question because recursion happens, right? You just have to handle it for small test case, and then you have this leap of faith. You leave it on that leap of faith that your code will run for the last cases as well. Okay? If you have read the question, well and good. If not, let us read it again and we will do it. So, what is given? The houses in Dholakpur are arranged in the form of binary tree and have Ladoos the same as their house number. Chota Bheem is standing at his home initially. Okay, they have taken the reference of a cartoon. Find the maximum Ladoos he can eat if he can go to the houses within the maximum distance of K from his house. The number of Ladoos at his home should also be included in the home. Okay, if you just consider this test case. So let me go back to my open board. Okay, again, we will not do the dry run for the large cases because that's not the optimum way to solve it. So we will take the smaller cases that 1, 2, 4, 9, 5 and 7. ठीक है. Observations क्या क्या होंगी यहाँ पे? अगर हम let's say हमारा target हमें मिल गया, then what we have to do? Forget about the code. What we have to do वो decide कर लेते हैं, ठीक है. So let's say we are at my target location, right? मेरे को क्या चाहिए कि हैव अ के इज पॉइंटिंग टू 1, तो मैं इस पर्टिकुलर 9 से के लेवल से नीचे जाऊँ, राइट? तो विल गो 1 लेवल डाउनवर्ड्स. इसके जस्ट नीचे वाले लेवल पे वैल्यूज क्या है 5 एंड 7 और हमें नोड इटसेल्फ को भी लेना है. तो माय सम विल बी प्रॉम्प्टिंग टू 9 + 5 + 7. ठीक है. सिमिलरली ये कॉल जब हुआ होगा, ये 9 वाला कॉल, ऑब्वियसली इसका कोई पेरेंट कॉल रहा होगा, पेरेंट तभी वो कॉल किया है इसको. एंड रिकर्जन हमें पता है whenever we make a call, whenever the task is done for the current node, it moves back to a parent call. ठीक है. ठीक है. तो दूसरी चीज हमें क्या करनी होगी कि हमें इस पेरेंट के पास जाना होगा, राइट? वी नो दैट माई करंट नोड वॉज प्रेजेंट इन दी राइट सब ट्री. ठीक है. अब मेरे को इसका भी मेरे पास है वॉट रेफरेंस ऑफ दिस पर्टिकुलर पेरेंट नोड ऑफ माई टारगेट नोड. ठीक है. अब मेरे पास दो क्वेश्चन है फॉर यू कि व्हाट शुड आई डू. शुड आई लाइक लेट्स से k इक्वल्स टू 2 होता है, राइट? तो मैं फिर से राइट हैंड साइड के सम को कैलकुलेट करूँ या फिर लेफ्ट हैंड साइड को? बड़ी ऑब्वियस सी बात है कि दैट विल नॉट टेक द राइट हैंड साइड बिकॉज द टारगेट नोड वाज इटसेल्फ प्रेजेंट इन द राइट एंड वी हैव अ फंक्शन that goes up to k levels in the subtree of it, right? And it formed. तो पेरेंट नोड जो है वो ऑब्वियसली लेफ्ट हैंड साइड में जाके अपना काम करेगा फॉर द k -1 levels, right? Somebody is at the door. Let me pause the video. Okay, I'm back again. So that was my observation. Ki if target node found in let's say right subtree RST, then for k -1 levels I need to find the sum from parent node of that target node, right? Or I can say target's parent, right? For k -1 levels I want to find the sum for target's parent in LST. I hope this point is clear. And this is the vice versa for the next thing. Vice versa. This is the two things we need to handle, right? Vice versa. Vice versa is nothing but if target found in LST, right, in the left subtree, then for k -1 levels, the sum of target parents will be formed in right subtree. So if you are clear till this point, I hope you will be, then we are good to go. ठीक है. तो हमें कुछ ऐसा रिकर्शन करना होगा, हमें कुछ इस तरह का ट्रैवर्सल करना है कि हमें जब नोड फाइंड हुआ तो k लेवल्स के लिए k -1 लेवल्स की सबसे पहले तो उसके डाउन स्ट्रीम में हमें नोड्स को निकालना पड़े, राइट? तो व्हाट सॉरी. So what is the task that we are doing? We are summing the nodes. So we will need a one more function, that is the sum, or let's say we'll make a function add, right? Where we will pass the root node. Root node is nothing but the node where from where you want to calculate the sum and till where. So that means the distance. We'll pass these two parameters and we'll do it So that would be a very naive code, right? If I just write it for you as the pseudo code, तो क्या हो जाएगा? हम एक आंसर वेरिएबल मेंटेन करेंगे. I will say n dot data or root dot data, right? And then I will recursively go for left and right while decreasing the distance. So I will say r dot left distance minus 1, and I will call for add function again, which is r dot right distance minus 1. So this was a very basic code just to add a node for a particular k level, and it's a very standard code. Maybe it's the third or fourth question when you study the binary trees problem. ठीक है, तो आई होप यू वेरी गुड टू गो, राइट? तो अब मैं अब इसका ड्राई रन दिखाता हूँ, ठीक है? पूरे टेक्स्ट के लिए ड्राई रन कि हमारा ट्रैवर्सल किस तरह से बिहेव कर रहा होगा, एंड देन वी विल गो अहेड विद द कोडिंग सेक्शन. So 1 5 7, what was it here? 1 2 and 4, right? ठीक है, so let's say we are first calling in the left traversal and then we are going to the right. So I will go on to left. Let me use a different color. I'll go on to left, and what would be the base case कि अगर हमारा जो null reach होता है, right? So in that case we will return -1, right? It will again go on to left, it will again go on to left, it will see that you have hit the base case, that is null, then it will return -1, right? And it will come back to my parent call. So the left traversal is done, it will go to right traversal, and then again it will hit the null, and what will be returned? -1, right? Then we will have that after traversing left, after traversing right, we will have some uh, inbuilt functions for this, because this is the thing that we want to do. These are the things we want to do, right? So that will be written here left and for left and right, and if both, and if that's not the case, right? Okay, and there will be one more if statement, that if we have found the target node, right? So how we can do that thing? So let's say when I found my target node, what will be the my pseudocode, how it will be reacting? Okay, so if I find my target node, so what I will say that if the recursive traversal that is happening, if that data is equals to what? My home is nothing but the target mentioned in the question, right? So what I will do, I will call for the function add root comma k, right? That go downstream for that particular target node, right? And add the sum, and I will say return k minus 1. Why I'm doing return k minus 1? Because this is where that, suppose you have reached 9, then what you will do, you will call this function, and then sum will have the answer as 9 plus 5 plus 7, right? Why we are returning k minus 1? Because still we have to go k minus 1 level in the upward direction, like we'll go till parent, right? And going to parent, we have already utilized 1 unit of k, right? And this parent, since the current target node has been found in RST, so this parent, what it will do, it will go for, it will call the function for add for k minus 1, but in the left direction, right? Because the current node we found, the target node we found in is in right subtree. Okay, so it will call for root dot left and comma k minus 1. I hope you get the point. So what it will do, k was basically equals to 1. So when it goes to parent call back, the k would be here is nothing but equals to 0. K minus 1 will be nothing but equals to 0, right? So it will just include its sum and will not go ahead. Let's say suppose k was equals to 2, right? Then it would have, for this parent, it would have taken its sum as well as this 2 as well, right? ठीक, तो ये हमारा हो गया 1. After this null statement, we'll have to code this thing as well, right? Now we have to use this thing. This is the remaining kth steps that the parent node has to take of the target, right? So let us do that. What I will do, that I will say int remaining is nothing but we will make a function solve, and what I will do, I will call for, let's say, root dot left. We found the node in right subtree, right? Okay, so what I will do, I will first mention, let's say, root dot right, and I will give you the one test case to do it yourself. So I'll call for root dot right. I'll pass the parameter home and then k, and I will check that if this thing which is passed in this remaining function, if it is greater than equals to 0, right? This remaining is nothing but this, it is catching this value. If it is greater than equals to 0, then you need to perform some things. And what is that things? that first of all you include your root dot data, and this root dot data is nothing but this thing. We are talking about this thing now, this root, right? And then you call the add function for your left part. So what I will do, I will call the add function for root dot left part. And what are the case steps that I have to pass? I have to pass remaining minus 1, and at last I will just return remaining minus 1, right? This will give you a negative integer value, and that is what we are checking. If it is positive, then only you have to do. If it's negative, you do not have to do it, right? Okay, let us come back to the dry run again. So this would be for the right part. Try to code the same thing for left part, right? Try to code it the pseudocode yourself. And if both the cases have been done, then you have to return -1. Okay, so देखते हैं अब इसको देखते हैं हम लोग. Since I have written some pseudocode, then let us see that how the dry run is performing. It will return -1. It will go to its parent call, right? And yes, so both has returned -1. So this will also return -1. Why? Because we have written the last statement as -1, right? It will call for its what? Right, and at right it will see that there is null again, so it will return -1. So I highly recommend you that please open your pen and copy as well and try to do this done myself, because this board can be a little messy in some time. Okay, so it will return -1 since both has returned -1. So this too will return -1. Correct. Now it will go for its right. This the parent call has been handled to this one. It will go for its right, and when it goes for it right, it falls in this test case. In our base case, right? This base case, that if root dot data is equals to home, that is, it is satisfying this condition. The add function will run. We have a global sum or answer variable which will have the sum of this current root, and it's all the sum of the nodes till k levels. So it will have 9 plus 5 plus 7, right? And that I have already shown you the pseudocode for that. Okay, so that's it. Now here, after forming this root, it will return k minus 1, because you still need to process for k minus 1 levels in the left part, because you have this node found in the right part. So again, it will return k minus 1, that is, it will return from here, it will return 0. Let me use a different color again. So here it will return 0, right? And this is now our parent. The call goes back to this parent, right? And again, we will call the add function for the left subpart for k minus 1. And that is what k minus 1 we are storing in this rem variable, remaining variable. Okay? Okay, so that is it. This is for the smaller test cases. If I do it for the larger test cases, the video would be very long, and that is not recommended at all, right? You have to build this leap of faith during the solving these three recursive problems, right? You will definitely face the issue of writing the code, right? But yeah, over that period of time it will come in handy. If not, then sometimes you have to take some hints and solutions, and you have to do it, and you have to build that skill. Okay, so video को pause करते हैं. Try to write this pseudocode in your thing, right? So what you will do, that you have to make this add function outside the original class function that is given. Then you have to make a static int answer variable, right? And then inside the main function which you have given, you have to make one solve function which has the parameters node, root, home, and k. And you need to mention these cases: the first case, the second case, and the third case. That is up to you. You have to use this pseudocode for the second case and try to write it, right? Okay, pause this video for now, maybe 2 to 3 minutes, and then resume again. Okay, so that's the code I have written. So first of all, we need to make an answer variable, it is a global variable. Why global? Because in recursion, you need to update this answer with the sum of the nodes. Okay. We have made an add function for a particular, when we found a particular home node, then what we need to do, then we need to do traverse k string downwards as well, and then the k minus 1 times the parent node in the downstream again, and you have to find the sum of the nodes. That is just basically finding the sum of the nodes. Okay, now we have a solve function. We passed the root, node, home, and k. So the first base case was that if it matches with the target node, then what you need to do, you call the add function, maintain the sum, and then return k minus 1. Why return k minus 1? Already explained to you, because this will add the k minus 1. This add this add will add k minus 1 downstream nodes, This return k minus 1 will add k minus 1 downstream nodes from the target's parent. ठीक है, ये बात आपको समझ में आएगी क्योंकि मैंने शुरुआत में ही ये 2 पॉइंट्स ऑब्जर्व करके आपको बताए थे. ठीक है, दैट्स द मेन लॉजिक. ठीक है, now I have mentioned for the left right traversal. Now you need to do for the left traversal. Let me explain you the right traversal. I've already explained it. Let me a code walkthrough. So this thing says that you have found your home root node, target node in your right subtree, right? Remaining is catching nothing but it is catching k minus 1, this thing, right? Because you can see that at 9 this base case will hit and you find the target node, right? And it will return k minus 1. So to which node it will return k minus 1? It's the parent call, and the parent call is 1. So it has the thing as k minus 1 in its hand, right? And we will check here that if it is greater than or equals to 0, then again make that root data. Sorry, my throat is not responding well. Okay, so we have to take that root data in your answer, and then you need to traverse left because you have found your target node in right for k minus 1 steps and return k minus 1 at the last, and this will give you a negative value, right? Yes. Okay, now please pause this video again and try to code the same steps if you traverse in the left direction. Or you can one more thing, you can code the left direction in line number 135 as well, on line number 144. Like you traverse left and then right, or you traverse right and then left, it remains the same, right? Please pause the video for 1 minute and code it yourself. And if you'll be like able to code it, then well and good. Like this means that you have understand the intuition, the observations which I showed you, that why are we traversing if we found the home route in the target node in the RST, then why are we traversing for k minus 1, the target's parent in LST, right? That was the logic. Okay, so like congratulations if you were able to do it, and if not, no problem, we'll do it from the next time. So okay, so we'll go in the left hand direction with the same parameters, and again we are checking if it is the remaining is nothing but this parameter, if it is greater than or equals to 1, and this this traversal will only be triggered when we found the target in LST. LST in the sense LST in the reference of this particular root node 1. And if you have found in the LST, then you go back to its parent. Let's say the target was equals to 4, right? Then it will go back to its parent call, that is 2, and then again or let's say the target was 2, right? This will make a complete sense. The target was 2, that is present in the LST. Parent call was 1 for this 2. It will go here and then it will again traverse for k minus 1 steps in this LST, and that makes sense, right? Because when you are at 9, right, what you do, you traverse k minus 1 steps downwards and you traverse k steps upwards, right? While traversing upwards, you need to have the reference of this node, right? And this node is nothing but your parent, your target's parent, right? That is it. Let us hit the compile button. I've tried my best to explain you this observation and coding part as well, because I believe that most of you guys have been uh, getting difficulty in coding this problem, because understanding it was very simple, and it happens usually with the trees because you can understand it well, but only thing, as for I'm speaking for myself, that I find it difficult to code it sometimes, right? There's no what to say, there's no bad thing in uh, accepting your, what to say, drawbacks. Okay, but in time we will eventually get that. Okay. So what would be the time complexity? That we are visiting each and every node once. Is that it? We are visiting every node once or more than once? Yes. So we are visiting each and every node once till we found this thing, the home node, right? And then the call goes back to the parent node, and then we visit it for k times upward and k times downward. So it will be n cross k, I guess, right? So 10 power 5 into 20. So this is a very constant thing. So it will not be a part in my time complexity. So the overall time complexity will be O of n. What would be about the space complexity? So I think expected is O of 1, but then again, I think they have not considered the recursive space, the recursive stack space, the solution took when you write the code for recursion, right? So it will again, it will be a O of height of the tree, right? O of height of the tree will be the space complexity. because you can clearly see that when you call for the left, right, so 1 goes to 2, 2 goes to 4, 4 goes to 8, 8 goes to 30, until and unless you are finding a home node. So these all calls are getting stored in a recursive stack, in an inbuilt recursive stack, right? So it will be O of height of tree. So that is it. So O of n, and n is nothing but 10 power 5, so definitely less than 10 power 8. So that is it. So if I hit the submit button, it would definitely get submitted. Let's hit the submit button. Also, I have mentioned all the comments here. You can clearly see that, read that as well if you are still not able to get the solution. Let us wait for a couple of seconds. Yes, so it has been successfully submitted. Also, the C++ users, if you are viewing this thing, I would request you, because I have some time constraint, I would request you if you would convert this code in C++ and mention down in the comments. It would be of great help for you and me as well. Till then, keep learning, keep growing. Bye bye, and take care.